How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at concentration of solution. So our objectives will be to describe the concentration of a solution in terms of molarity and to determine the molarity of compounds and electrolytes in solution. So what is concentration? Concentration is simply how much stuff is in a certain volume, certain area, right? So if we're talking about solutions, we're talking about how much stuff is dissolved. So if we have more stuff in the same area, we call it more concentrated, right? If we have less stuff in the same amount of area, it's less concentrated. So between these two pictures, the top one is less concentrated, where the bottom one is more concentrated. So in solutions, the stuff that gets dissolved, we call the solute. So that's a term you should be familiar with. The thing that does the dissolving is called the solvent. So if I'm making lemonade and I got my lemonade mix and some water, the solute would be the mix because that's the stuff getting dissolved, and the solvent would be the water because it's doing the dissolving. The mixture of the two we call the solution. So when you talk about the whole thing, those things mixed together, that's the solution. The lemonade drink that I made is a solution of sugar, water, and like lemon juice. In chemistry, we often measure how much stuff in terms of moles and volume in terms of liters. So we have a unit that tells us how many moles we have per liter. We call it molarity. It's abbreviated by a capital M. So molarity is a unit of concentration that is often used in solution chemistry, right? So I got a little picture of a mole just because they're cute. It has nothing to do with molarity, but they're cute. Look how freaking cute they are. Anyway, molarity is equal to moles of solute divided by liters of solution. Right, so this is going to help us determine how much of a chemical is in a certain volume that we can measure. So this way we can just measure out 100 milliliters and we'll know how much solute is in it. It's abbreviated by a capital M. So if you see 1.0 capital M, it's saying it's 1 molar, which is 1 mole of solute per liter of solution. If it's 2 molar, it's 2 moles of solute per liter of solution, right? So how do you make a 1 molar solution? How do we do this? You might think just add a liter of water to a mole of solute, right? You'd be like, just mix the two. But no, that's wrong. Why is that wrong though? That's 1 liter. That's 1 mole. This is 1 liter of water, which is our solvent. And our molarity is moles per liter of solution. Not of solvent, but of solution. So the way you do it, why this messes up is because that solute takes up some volume. So when you add 1 liter to the stuff you're dissolving, you don't end up with 1 liter of solution. The solute takes up space too. So how do you make a 1 molar solution? First, you measure out the mass of solute needed for your desired concentration. So if I wanted to make 1 liter of 1 molar sodium hydroxide, I would need 1 mole of sodium hydroxide, which is 40 grams. So I would take 40 grams of sodium hydroxide and I would put it in this volumetric flask. So now it's chilling at the bottom. Now I'm going to add, that's the step. Step 2, add the solute to the volumetric flask. Third step, add some water. So now I'm going to add a little bit of water into here and fill it up just a little bit, and then I'm going to swirl it around and shake it to dissolve it all. Once it's all dissolved, then I'm going to add more water until I reach my final volume. So in this case, it'd be 1 liter. So with volumetric flasks, you can see there's a little etched ring at some point on the neck. You can see it in this picture right here too. And that ring marks exactly 1 liter for this volumetric flask. So I'm going to fill up the water until the bottom of the meniscus hits that ring right there. And then I know I've made 1 liter of solution. At this point, you could stopper it and shake it to make sure that it's mixed up thoroughly. So example, what is the molarity of a solution where 0.250 moles of sodium sulfide is dissolved in enough water to make 2 liters of solution? So it wants the molarity, and we know that's moles of solute divided by liters of solution, which I'm going to abbreviate SOLN. So we have 0.250 moles divided by 2.0 liters of solution. So I do that and I get 0.125 molar. And when I round it to correct sig figs, there's only 2 there. This is going to become 0.13 molar. And that would be my final concentration. All right, what about the concentration of electrolytes in solution? What do I mean? Well, electrolytes break apart into different ions when you dissolve them in water. For example, sodium chloride breaks up into sodium ion and the chloride ion. Right, so it starts off as one compound, but when you dissolve it, it splits apart. Now, the concentration of these ions depends on how many ions are produced when you dissolve that solute. So, for example, one single NaCl is going to split up into one Na plus and one Cl minus. If I had a different compound, though, like calcium chloride, well, notice it's CaCl2. It's going to split up to give me one calcium ion and two chloride ions. Oh, I don't know why I do third one there. Oops. So two chloride ions. So it's going to give me a total of 3 ions, one calcium ion and 2 chloride ions. If I had this sodium carbonate, all right, how is this going to split up? Well, I know the sodium is going to split up into 2 sodium ions from that Na2. And I know CO3 is a polyatomic ion. All those nonmetals are going to stay together as one ion. So I'm going to get one carbonate ion. So you're going to end up with 3 ions total from that. So in order to determine the concentration of an individual ion, like what's the concentration of the chloride ion, or total ions in solution, you have to look at how it ionizes. So let's take a look at this. A solution is prepared. Hey, this looks a lot like my last one. So what's happening is I know Na2S is going to split up to become 2 Na pluses and a sulfide minus 2 ion. So what is the concentration of Na2S? Well, we already determined it to be that 0.125 molar, which then, rounded to 0.13 molar. So what is the concentration of the sulfide ion? Well, for every one compound, I end up with 1 sulfide ion. So it's going to be the same thing. It's going to be 0.13 molar. But what about the sodium ion? Well, for every one of those compounds, I end up with 2 sodium ions. So it's really going to be like this. It's like 0.13 molar for Na2S. But then we want to go, well, for every 1 mole of Na2S, we get 2 moles of Na plus. So we're timesing that by 2, and we get 0.26. It'd be twice as much because we get 2 sodium ions from it. And then what is the concentration of ions in solution? Well, I get 3 ions from 1 sodium sulfide. So I would have to do this 0.13 times 3. And I'd get 0.39 molar would be the concentration of all ions in solution. We're converting between moles, molarity, and volume. So here's our equation. How do you rearrange the cell for moles? How do we get moles by itself? Well, it's simple. You times both sides by liters, right? If I got molar equals moles per liter times both sides by liters, liters cancel out and you get moles equals the molarity times liters. Well, what if I wanted liters? All right, well, first step, molar equals moles per liter. I don't want liters on the bottom, so times both sides by liters. Liters cancel out over here, but now I want liters by itself, so divide each side by molar, and you end up with liters equals moles divided by the molarity. Something to note is oftentimes they give you a volume in milliliters. A lot of times we work with milliliters in the lab. And remember that 1 liter is equal to 1,000 milliliters. And when we're solving for moles, our volume has to be in liters. So how many moles of NaCl are in 250 milliliters of a 2.0 molar solution? All right, well, I know if I want moles, I'm starting with this. I got to rearrange. It's going to equal the molarity times the liters. So the molarity is 2.0 molar times by, oh wait, I got milliliters. How am I going to get liters? It's going to equal milliliters divided by 1,000 because there's 1,000 milliliters in 1 liter. So I do 250.0 divided by 1,000 and I get 0.2500 liters. And let me show you the units. Moles per liter is molar, right? So liters cancel out, and when I multiply that together, I get 0.50 molar. 2 sig figs in my molarity, so I keep 2 sig figs in my answer. All right, what about how many milliliters of 6 molar HCl solution are needed to give 1 mole of HCl? All right, well, let's figure this out. I want 1 mole, and I need to get milliliters, so I need the volume. I know molarity equals moles per liter. If I rearrange that, I get liters equals moles divided by molarity, right? And if I wanted milliliters, then I do moles divided by molarity times 1,000 milliliters per liter. So let me plug in some numbers. Let's see. I need 1 mole, 1.0 moles, divided by 6.0 molar times by 1,000. And I end up with, I didn't do this math, 1 divided by 6 times 1,000. Beep bop, boop. To 2 sig figs will give me an answer of 170 milliliters. So yeah, there you go. Summarize. Can you describe the concentration of the solution in terms of molarity? And can you also determine the molarity of compounds and their electrolytes in solution? I hope so. All right, goodbye.